Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, taking a look at part 2 of lesson 6.2.5. Depending on when you choose to take your check for understanding, you might recognize this, or maybe you don't. So if you have not yet seen this problem, then that means you have not done the check for understanding yet. And if you have seen it in the check for understanding, hooray, you've already got this problem complete, and you can just move on to the next problem. I'm going to go through it anyway. It says Yosemite Falls, the highest waterfall in the United States, is actually made up of 3 smaller waterfalls. You got the lower Yosemite Falls, which is 350 feet shorter than the Middle Cascades. And you've got the upper Yosemite Falls, which is 80 feet more than twice the Middle Cascades. So we've got lower Yosemite Falls. You've got the Middle Cascades, and you've got the upper Yosemite Falls, which is being compared to the Middle Cascades. So it seems like we should make the Middle Cascades our X. So that makes the lower Yosemite 355 feet smaller than that. And the upper Yosemite Falls would be 80 more than twice the length. Is that what we're calling this? Is the length? I guess I don't know what we're calling it, whatever. So, and then it says that the total, when you combine all of them from top to bottom, is 2,425 feet. So I'm going to go ahead and take, here is your lower Yosemite, here is your middle. No, that is not right at all. Hold on. We are making, this is our Middle Cascades, this is our lower Yosemite, and this is our upper Yosemite, and then here is the total. So let's go ahead and combine like terms. You get 4x, and then negative 355 plus 80 is negative 275. So I'm going to add 275 to each side, which cancels them out here. And then we are going to divide by 4, and 2,700 divided by 4 is 675. That means that the Middle Cascades must be 670, stop it, must be 675 feet. Oh, I've got it written right there. Okay, don't need to write it again. Now, take 355 away from that, and you get 320, and then double that number and add 80, you get 1430. If all of these meet those definitions and add up to 2,425, we know we've got the correct answer, and we do, so we can declare our answer right down here. All right, evaluate the following expressions. The reason why you want to evaluate is because this is how you check your solutions when we are solving equations. So if we had an equation where we solved it and we realized that x, or at least we think x is equal to 9, then we should be able to plug 9 in to the equation and evaluate the expressions to make sure that both sides of the equation have the same value. So to do this, you just take 7 times 9. 7 times 9 is 63, and then add 8 to that, and you get 71. So this one is going to be 71 after you've evaluated it. Here we're going to plug in a negative 6. It becomes negative 6 minus 11, which is the same as negative 6 plus a negative 11. That becomes negative 17. So what is 6 times negative 17? Well, use your calculator. You'll see it's negative 102. And then here we're going to plug in the negative 4 here. So that becomes 45 minus 5 times negative 4. So it becomes minus, oh, and plus 7. So that's going to become minus a negative 20, which eventually is going to become plus a positive 20. So once we get this subtracting a negative thing squared around, now we're just going to add straight across. 65 plus 7 is 72. And then here, wow, we got a lot of multiplying negatives times negatives, don't we? Well, I guess we've only got 2 of them, but still. Negative 2 times negative 20, you're multiplying a negative times a negative, so you're going to basically take 2 times negative 20 and then take the opposite of that, which becomes positive 40. And 40 plus 9 gives you your 49. All right, here are some new distances with given lengths to help Cecil cross the tightrope. Find at least 2 ways to get Cecil across for each situation. So this takes us all the way back. I can't remember if this was chapter 2 or chapter 3, but very early on in the school year when we were looking at different ways that we could create expressions using these distances to equal this quantity. Okay, so it says 2 different ways. There are infinite number of ways that you can do this, since you can go forward or backwards. And so, you can just look at my answers and then look at yours and decide if you remember how this works, the basics of it. Using each one of these numbers, does it say only one time or at least once? Because if you can only use them each one time, that isn't going to give us an infinite number of possibilities. There would be a finite number. But here, I see what we're doing. 3 times 5 is 15 plus 4. So 3 steps of 5. Oh, and I didn't even use the 7 in that scenario. Okay, so use each number as many times as you want, and you don't have to use them all. How's that for a roll? We'll let you pause and look at all those, make sure you got, if yours are correct. All right, Walter walked 15.5 blocks from his house to work. It took him 35 minutes. So there's a ratio of the number of blocks. We could convert that to a unit rate, by the way, if we wanted to, and take 15.5 divided by 35, and that would be, oh, that's a terrible number. We would, I suppose, round that to 0.44 blocks per minute. Or you could invert it, you could turn it around, and you could say 35 divided by 15.5 and say that's also horrible. That's like 2.26. 2.26 minutes per block. You can write the unit rate in either one of those ways. But since both of those gave us such horrible repeating decimals, I'm going to suggest we just go to old reliable, cross multiply, and then divide. And of course, we're still going to have to round it, but we round it at the end of the process instead of toward the beginning. So 15.5 times 60 is 930, and 35 times x is 35x. So when you divide each side by 35, our answer is going to be whatever 930 divided by 35 is. And that's one where you would just round it off. Maybe 26.6 or 26.57. That's what I chose, is 26.57 blocks. And that's per hour, right? And that's why we have 60 minutes there, because 60 minutes is the number of minutes in an hour, so we want to make sure the unit of measurement is consistent for our proportional reasoning. All right, this looks like an inequality situation. Well, let's just read it. Jenna's mom gave her $100 to shop for some new clothes. I'm going to highlight that. That's important. That means she can spend a maximum of $100, but she could spend less if she wanted to. She is at the store and has picked out a pair of pants that cost $49.50. I'm guessing she's going to buy those pair of pants no matter what. She wants to spend the rest of her money buying various colors of shirts that are on sale for $12.99. So those are the shirts, and we're going to make X represent the number of shirts, because she could buy 1 shirt, she could buy 2 shirts. Could she buy 3? Could she buy 4? I don't know. So if we solve this equation, or inequality as it is, we will be able to determine the maximum number of shirts that she can purchase. So let's work through the process and subtract $49.50 from 100. That's going to give you $50.50 that she can spend on shirts. Okay, so if 1 shirt is $12.99, then 2 shirts, what is that, almost 13, would be $25.98. And 3 shirts would be, what is that, 17, carry the 1, that's going to be 18, 19, carry the 1, that's going to be 38, no, not 38, that's going to be an 8, oh, it is 38, $38.97 for 3 shirts. And what about for 4 shirts? $38.97 plus 12.99. Can she buy 4 shirts? No. That would be $51.96, but she only has $50.50 remaining. So you cannot buy 4 shirts, but you could buy 3 shirts. Okay? So this is doing the problem without solving it algebraically. But to solve it algebraically, remember, we subtracted $49.50 from 100. Nope, that's 50. So 49.50 subtracted from 100, that's how we got the $50.50. And then when you take that and divide it by, 12.99, that's how you would get this as your answer, 3.89, which probably rounds off. But she's not going to buy 89 hundredths of a shirt, so she would have to stop at 3. And this kind of explains that 4 won't work, but 3 does. That's it. Hooray. All right, let's stop it. There we go. All right, let's move on to the next activity, which is probably a check for understanding. Take care. Bye. Bye.
Hey, feeling good, like I should. When in dark, walk